Now, our next speaker is Adrian Boguszewski, who's a seasoned expert in the field of computer science. And Adrian embarked on his journey in computer vision and deep learning right after graduating from the Gdansk University of Technology 8 short years ago. So Adrian's got a rich background as a team leader of data scientists and Android developers, and he's been instrumental in crafting applications that redefine convenience, such as the innovative solution for capturing professional photos from the comfort of one's home. So in addition to his practical contributions, Adrian has left a mark as a co-author of the landcover.ai dataset and as a creator of the OpenCV image viewer plugin. And he also generously imparts his knowledge as a deep learning lecturer enriching the AI community. Bonus points there. So today, Adrian is here to guide us through the creation of an intelligent queue management system, which is a solution posed to revolutionize retail checkout experiences. So by leveraging the formidable combination of OpenVINO and YOLO version 8, Adrian will provide us with a detailed tutorial on building this system from the ground up. His expertise is going to illuminate the process of integrating these powerful open source tools to develop a seamless end-to-end solution that promises to enhance retail environments. Tick, tick, tick. So whether you're a seasoned developer or just beginning to explore the realms of AI, Adrian's session is going to equip you with invaluable insights, practical tips, and best practices for constructing intelligent systems using OpenVINO. My dear friends, please give a huge round of applause to Adrian. Thank you.
Welcome. My name is Adrian. I am AI Software Evangelist at Intel. And today I would like to tell you how to build smart queue management system with YOLOv8 and OpenVINO. OpenVINO for great performance, of course. And yeah, this is me. I was deep learning engineer before I joined Intel, so I have much of experience, technical experience, and I know how it's difficult to get great performance from deep learning networks. And as I said, I am AI software evangelist right now, and my role is to teach people about OpenVINO, why you need it, and how to use it. And first, let's talk about the challenge, why you need to build intelligent queue management. Do you know how many people are waiting in this line? Of course, we can count, right? 1, 2, 3, 4, 5, 6, 7. There are 7 of them, but it's manual job. Do you want to do this yourself? What if there are more queues? If there are more stores, for example, when we count people staying in lines? I don't think you want to do it. It's better to create some automatic solution, right? Some algorithm to do that. And yeah, that's what we want to do here. We want to use some video stream, then we want to use some deep learning algorithm. In this case, it will be YOLOv8, and we want to do it automatically. And so what is intelligent queue management in this case? What I am talking about? I'm talking about solutions like this, that we specify regions of interest, we count people in these regions, and when some queue is over capacity, we let the store know that more store assistants are required, maybe we need to open one more line or something like that. Let's look also at high-level overview of this solution. It can be broken down into 4 steps. The first step is, of course, video capture. Then we are going to detect customers, in this case, detect people. And then we count these people in specific regions of interest. And after that, we alert that some queue is over capacity. So if we look at the first step, video capture is a standard video stream. It can be video file, but in most cases, of course, it's good to have live video stream from some camera. Then we detect customers, and for that, we are going to use Ultralytics YOLOv8. Why that? Because it's state-of-the-art model, which achieves great accuracy and have great performance. But what else? If we look at these charts here, we see that nano model is the fastest one, and the large and Ax large are the more accurate. So what we want to do here is to bring all the dots from right to left to run large models or X models as fast as we can run S or nano version. And that's why we are going to use OpenVINO, and I will tell you something more about that a little bit later. And there is a third step when we count these people standing in these queues. So we specify our regions of interest. And if some queue is over capacity, we alert the store assistant that maybe a new line has to be open. And that was high-level overview of the solution. I'm going to show you code in a while. However, first, I need to introduce you to OpenVINO toolkit, otherwise you don't know what I am talking about, right? So OpenVINO is an open source toolkit for optimizing and deploying AI inference. So it's open source. Absolutely any one of you can use it, and OpenVINO gives you better performance. OpenVINO also stands for visual inference and neural network optimization, but this was only beginning. Right now, it supports also NLP, audio, generative AI, large language models, and many, many others. And let's assume that you have your model in one of these frameworks: PyTorch, TensorFlow, Keras, TensorFlow Lite, ONNX, Kafka, or Paddle. Then you need to convert that model to OpenVINO format, and you are able to run on many Intel's hardware like CPUs, Atom, Core, Xeon, but also ARM. We added support for ARM recently, so you are able to run on your Mac, for example, Raspberry Pi, or even Android. We also support GPUs, Intel GPUs, like for example, Iris, and Iris is integrated GPU. So when you buy your CPU like Core, you have already their integrated GPU. This computer, for example, has that GPU available here, so you don't need to buy any discrete GPU card. You can use that hardware you have already. Probably most of you have Intel CPU in your laptops, right? So it's very probable that you have also integrated GPU. But we also support Intel discrete GPUs, like recently released Arc series or Flex series available in our servers. NPU means Neural Processing Unit, and it will be available in our new Intel Core Ultra, which will be released December the 14th. And it's a specific unit for running neural networks on CPU for, of course, great performance. Of course, we also support FPGA through FPGA ASUT, and you can run OpenVINO on any operating system, Windows, Linux, or Mac. And what I need to introduce you also is neural network compression framework, because OpenVINO is just part. The second part, and neural network compression framework, is included in OpenVINO toolkit. It's tool for compressing models. So let's assume that you have model in one of these formats, TensorFlow, PyTorch, ONNX, or OpenVINO. Then you can run some of these algorithms like post-training quantization, accuracy control quantization-aware training, but also filter pruning, binarization, or sparsity. And after that, you end up with some compressed model, some smaller network, quantized network. It means that it should be faster to run, and it is. And if we look at these results before and after quantization, on the left you have images. Before it's the top one, the after is the bottom one. So we are able to detect the same objects. Maybe probability is a little bit different after doing quantization, right? But that's okay, right? We still are able to detect all the objects here. And if you look on the right, we have the comparison between floating point 32 and int8 quantized model, mean average precision. And I would say that the accuracy drop is negligible. And it's as small as this because we use some specific quantization algorithm. It's post-training quantization. However, we skip some operations. I will show you later what we skip because some operations can be skipped for better accuracy, not impacting performance as much. And now it's time to look at some code, right? Because that's most interesting part of this presentation, I hope. So this project is open source also. So if you would like, you can scan this QR code in top right corner and you will go to our GitHub repository and you can try this project at your home. So I'm going to go through the steps like installation. I'm going to show you how to install that project, how to run it. Then we will talk about conversion. We need to convert our YOLOv8 model to OpenVINO format. Then optimization. In this case, it will be post-training quantization. Then I'm going to tell you how to run the final application with this model. And I'm also going to show you live demo. Then let's talk about performance benchmark, how it works on Intel's hardware. And then let's talk about very important part, deployment, right? Whatever we develop, we would like to deploy it at the end. So let's start with installation. So this project is stored in our OpenVINO notebooks repository. So you need to clone the repository and switch to branch recipes. Alternatively, you can just clone the recipes branch and then change directory to intelligent queue management. After that, of course, we recommend to create virtual environment. This is a good solution for any Python project and activate that environment. Then you need to install requirements specified in requirements.txt file. And it's all. You are ready to run the code. So let's talk about conversion right now. We need to convert YOLOv8 from PyTorch format to OpenVINO. So YOLOv8 is in PyTorch, but also Ultralytics provide you YOLO exporter in their Python package. So we are going to use this exporter to export the model to OpenVINO format, which is called intermediate representation, IR in short. And it consists with two files, XML with architecture and binary file with weights and biases. In this case, we are going to convert to floating point 16, of course, to have better performance than floating point 32. Okay, how the code look like? So first we need to import Ultralytics package. Then we specify the model we would like to use. In this case, we are going to use YOLOv8M, M for medium. So we are not going to use the nano version, the fastest one, because we think that the sweet spot is exactly here. So it's as good, as accurate as performance, something like that. Then we, of course, create that model using standard API, and then we export it to OpenVINO using Ultralytics YOLO exporter. So we specify format OpenVINO. We also specify that half equals true. It means that we would like to have floating point 16 instead of floating point 32. And we say that dynamic equals false. It means that the input size will be 640 by 640. So it won't be dynamic in this case. But of course, you can use dynamic as well. And then let's talk about quantization. So this is part of our optimization to bring even more performance to you. So post-training quantization requires us to, maybe let's start with what quantization is. It's just converting the model from floating point domain to int domain, to integer, right? In this case, we will end up with int8 model for great performance. We need to provide two things. The first thing is, of course, OpenVINO model. In this case, it will be in floating point 16 precision. And we also need to provide a representative, sometimes called calibration dataset. As YOLOv8 was pre-trained on Coco dataset, we use Coco validation dataset as our calibration dataset. And we do post-training quantization to get int8 quantized model. Once again, let's look at code. So let's start with data preparation. So first we import some Python packages like NumPy, NNCF, Ultralytics, Torvision, and so on. Then we specify our Coco validation dataset. We create that Coco validation dataset specifying paths to data on disk. Then we create the data loader with batch size equals 1. We want to shuffle data also. Then we need to specify transformation function. In case of quantization, we don't care about labels. We care only about data. So we skip the label here. And we create calibration data set in NNCF format. And data is ready. Now let's load our model. So Let's import OpenVINO, then let's initialize OpenVINO by creating core object, then let's read our model from disk, and we are ready to do the quantization. So then we specify some ignored scope. That's what I mentioned before. So we will have great accuracy because we ignore some operations like multiplication, subtraction, and the sigmoid. They don't change much in case of performance, but they change much in case of accuracy. That's why we ignore them. And then we run the quantization using quantize function from NNCF. We provide our OpenVINO model. We provide our prepared quantization dataset, and also some additional configuration like preset and ignored scope. After that, the model is in our memory, so we need to save it to disk using serialize function. And that's all. The model is now ready to be used. So let's talk about the application itself. So we have our video stream, then we have our detection part, which consists of 3 steps. Pre-processing, of course, then inference part with YOLOv8 M and 8 precision, and then post-processing to create boxes around objects from raw results from the network. After that, we need some kind of interpretation, right? We just detected objects here. We need to filter out, to filter only people. Then we need to specify also regions of interest, and we specify customer limit because we would like to know how many customers is enough for one queue. And after that, we have some kind of output. In this case, we will have output stream, so we will see all detections on the image. However, you can have any kind of output. So, for example, you can generate some alerts or database records, whatever you prefer. How to run the application? So there are 2 ways. In this project, you can run the scripts. So the first script, of course, is convert and optimize when you convert model to OpenVINO format and then quantize it. And then you can run application running app PY script, where you specify stream you want to use, path to the model, also configuration of zones. Zones mean these areas of interest, and customer limit. So this is the first approach. But there is also a second approach when you can launch notebooks. So if you need more description, explanation, if you would like to understand more, just run the notebooks and see everything there. If not, if you are good with scripts, run the scripts. So 2 ways available. And now it's time for live demo. So I'm going to run the code right here. Let me switch to, yes, I think it's visible. So I'm running the notebook here, run the application, which is available in this project. So what we have here, of course, we first import some Python packages like NumPy, also OpenVINO, and some others, also supervision. We use supervision from RoboFlow. I think maybe you heard about it. Then we have some pre-processing functions like letterbox to keep the ratio of the image. Also, we convert the model to, maybe I will run in presentation mode. It will be bigger. So we convert to floating point 32. Even the model is int8. We convert the input to floating point 32 because it will be converted then to int8 automatically by the network itself. Then we normalize, of course, the image, transpose it, and create bar size equals 1. Then we specify our post-processing functions like non-maximum, of course, doing non-maximum suppressions and returning the detections in supervision format. It will be useful later when we want to use supervision for auto filtering, auto drawing on the image, and so on. Then we have function to get the model. We initialize OpenVINO, read the model, and compile it for some specific device. In this case, we will use auto. Auto means that the OpenVINO will select the best device for you. Okay, of course, you can specify the device yourself here. So, for example, you can specify CPU, you can specify GPU, and of course, I mean this GPU here in this laptop, right? So I'm not using any discrete GPU card here. And we specify that if we care about latency, right? Because this is latency application, so we would like to get results as soon as possible after the frame arrives. Then we load our zones. These are regions of interest. We also create annotators in supervision format then to annotate our image with polygons. function to draw text on the image, and main processing function where we get our model. We create video player, which can play a video file or video stream from your webcam. We are getting frame by frame here, doing pre-processing here, measuring time for inference. The inference is here, exactly this line, and then doing post-processing, and then is annotation, so drawing everything on the screen, also showing inference time, so you will see how good it is in case of performance, and we show everything. We can show it directly in Notebook or in pop-up. And let's run the application then. We are going to use pop-up in this case, and you can see in top right corner the performance. However, wait a little bit because, yeah, it will be better. Startup of time is, of course, taking some time, and we have almost 30 frames per second. Of course, now I am streaming, I am presenting something else, so my CPU is quite heavy loaded. So, but I remember that I had 35 or even 40 when it was running just this application. Oh, it's right now 35, so good. And as you can see, it's detecting people, so we use YOLOv8 to detect people. We use supervision to filter people objects, because YOLOv8 detects all objects available in Coco dataset. And then we inform that some queues are over capacity in top left corner. I hope you saw that alerts flashing them. And 35 frames per second just running on this computer here. So I am not using any cloud. Everything is running on this edge, on this CPU you have here. And I think this is great, right? Because I think most of you has Intel CPU in your computer, so you can utilize that CPU using OpenVINO. I would say that this is free lunch. You don't need to buy any additional hardware. You can utilize what the hardware you have already. Okay, let's switch back to PowerPoint. So let's talk about performance. I showed you running live demo here. However, I also did the performance benchmark for you, and I tested i7 CPU, also iGPU for that CPU, also Arc DGPU, Flex DGPU, and Intel Xeon. And what we can see here, all of these are related to YOLOv8M. So it's not nano model, right? Nano model is much faster. I tested on this computer 1 week ago, and I got more than 110 frames per second running nano model. But this is M, medium model. And so we have, even for medium model and even running for Intel's i7 CPU, we still have real-time performance, right? The real-time performance, I mean 30 frames per second. This GPU here, oh, it doesn't work. Okay, the GPU you see, Iris Xe is from Intel Core i7 just above. And of course, if you have more streams, so if you have more streams, Xeon is the right choice, right? Because it can serve 8 streams in parallel. When we multiply 30 by 8, it gives us 240, and Xeon is able to run more than 250. There is, of course, in most cases, Int8 is faster than floating point 16, and it's expected. But in case of DGPUs, Flex and Arc, we don't see much difference, right? And the question is why? And the answer is because OpenVINO has that feature which is called default inference precision. So for example, if you provide Int8 model for DGPU, discrete GPU, which is the best in case of floating point operations, the precision will be automatically converted, right? So it won't give you an error that I am not gonna run Int8 because I don't know how. It will be automatically converted to floating point 16. That's why we cannot see any difference here, because all of them, Int8 or floating point 16, run in floating point on these discrete GPU cards. And we use, for benchmarking this, we use the benchmark app. You can see the command line at the bottom, right, when we specified some device path to the model and hint that we care about latency. Let's talk about the deployment then. We give you 2 ways, you remember, Jupyter notebooks to understand how it works, and also we give you app script for easy deployment. And so we can deploy this on any single board computer, like those running Intel Atom, but also laptops like with Intel Core or Intel Arc discrete GPU. It means more PC than laptops, but of course it's that kind of device. And also you can run on servers with Intel Xeon and Intel Flex GPU. So how it doesn't matter how many streams you have, it's just the selection of the right hardware. And I showed you that we are able to count people standing in queues, right? But just changing one line of code in this project, and you can count almost anything. You can count cars, buses, workers, sheep, cows, and so on. And I say almost anything because YOLOv8 was pre-trained on Coco dataset, so that category must be in that dataset, right? But if you have your own model trained on anything else, of course, you can use it here, and you can use that project to count whatever you want. And this project is open source, and also it's part of Edge AI reference kits from Intel. It's just there in the middle. So we have even more. So if you are interested in, for example, reading meters, analog industrial meters with OpenVINO, there is that project also. If you would like to detect cracks or scratches on items running on conveyor belt, for example, you can check out defect detection with Anomaly. So scan this QR code to see our others Edge AI reference kits. And if you don't mind, this is let us know what you think. This is a QR code for survey. But if you are here in person, I have a better deal for you. I have paper surveys, and if you fill them for me, I'm gonna draw 3 lucky people winning this. I call it survival pack because it's waterproof backpack. Inside there is a travel mug, OpenVINO of course, and the most excited thing, solar power bank, so we can recharge it with sunlight. So just come to me, fill the survey. Please leave your name there, otherwise I cannot identify you. And at the end of this conference, after the closing, please come to me, give it to me, and we will draw 3 lucky people winning this. And I showed you our project, one of our Edge AI reference kits to count people. But as I said, you can count almost anything. And I recommend you trying at home. And of course, my main takeaway from today is you don't have to buy any additional hardware. You can use hardware you have already in your laptop, and you can have great performance just for free because you use OpenVINO. That's all from my side.
Fantastic. Adrian Boguszewski, man with the swag. Make sure you fill out that survey. You could win one of those amazing survival kits. Bonus points for the solar-powered charger, waterproof backpack, drinking cup, tick, tick, tick. Okay, we got a few minutes for questions. Do we have any questions? That was such a great presentation. I mean, that live demo of the supermarket, it reminded me, sorry, dad joke coming up. Every time I go to the supermarket, I want to open some vino straight afterwards. So, sorry, okay, thank you. Thank you for not throwing anything at me. Okay, Talia, what say you? Do we have any questions online? Do we have any questions in the room? We are ready for your questions, but that was just an awesome presentation.
Okay, so Adrian, can you briefly explain the integration process of YOLOv8 into the smart queue management system?
Yes, so YOLOv8 is the model to detect objects there, right? So we use YOLOv8 to detect objects, then we filter people only, and we use YOLOv8 with OpenVINO for better performance. But this is a key thing in this project, right? Because it allows us to detect those people there.
Awesome. And we have, how can queue management help in retail business? Do you have any real life examples that you've seen?
Well, this is like showcase only, so it's not a product, right? We don't sell it. We just say you can create something like that following our notebooks, following our project, right? So yeah, I think it can help in retail, removing removing queues or decreasing the size of queues, but also it can help for traffic. For example, if we are able to count cars on crosses, right, and then manage the traffic better because of that, I think it's a nice solution. But this is, as I said, this is open source for all of you to create great products and to sell them to market.
Nice. There's an invitation if I've ever heard one, or also a challenge. Talia, do we have any more questions on the interwebs?
Yes. So what specific hardware requirements are necessary to implement the smart queue management system with YOLOv8 effectively?
So it depends how many streams you have and depends which model you want to use. So I showed you that running on this laptop, we are able to run one stream, and this model was YOLOv8M medium. But if you run nano model, this laptop is able to run 4 streams in parallel. However, if you have more streams, like let's say 15 or something like that, and you still want to use N model or something like that, I think you need to buy to get some discrete GPU or something more powerful. But of course, it depends on the model and how many streams you have.